Hi everybody. So with radicals in place and complex numbers in place, we are now in a position to solve equations that don't necessarily, quadratic equations that don't necessarily factor well. Alright, so for example here we're going to solve x squared equals 45. Well, if we took the square root to both sides, now when we do that, the left hand side will just be an x, but the right hand side, we do need to write plus or minus the square root of 45. Okay, the reason we're doing that is because there is a negative times a negative that will come out to be this 45 here, okay? So, I do have a perfect square that's hidden in a factor of 45. That's a perfect square that's hidden in there. It's the 9. So 9 times 5 is 45. 9 is going to come out and become a 3. So my answer is going to be x equals plus or minus that 3 times the square root of 5. Well, let's crank this up a notch. Suppose we had 5x squared minus 55 equals 0. So you do want to solve for x here, or isolate for x. So I'm going to add 55 to both sides first. That'll give me 5x squared equals 55. Then we'll divide by 5. So now we're looking at x squared equals 11. And then we're going to do the same thing I did over here, right? I'm going to square root both sides of the equation. That'll give me an x on the left and a plus or minus the square root of 11 on the right. So that one's done. Let's crank this up another notch. We'll solve the square root, 3x minus 1 quantity squared equals negative 4. So we want to square root both sides of the equal sign. Don't forget that plus or minus on the right. So we've got 3x minus 1 equaling a plus or minus the square root of 4i, the square root of a negative 4 is 2i. So now we'll add a 1 to both sides. So we're looking at 3x equals 1 plus or minus 2i. Okay. And then we will divide by 3. Notice how I'm doing that though. I'm not just going to divide the whole right side by 3, because I want this in what's called complex form, a plus bi, a plus or minus bi here. So I'm going to divide all 3 terms by a 3, and that'll give me x equals 1/3 plus or minus 2/3 i. Alright, so that problem is now done. And next up, it looks like I've got time on this video. I'll go ahead and try this. I'm going to crank this up another notch. I'm going to do this thing called solve by completing the square. And I may have to do several of these, because this will be a new concept to some people. So let's solve x squared plus 8x equals 1. This won't factor, right? If I try to subtract a 1 to the left side and try to factor using the zero product rule, it's not going to work. So I've got to do this thing called completing the square. Now there is another way called using the quadratic formula, which you probably have heard of. And I will cover that, not in this video, but in a future video I will. But how completing the square works is first isolate for your all terms that have an x in it on one side of the equal sign. And the leading coefficient must be a 1 here, okay? And then what you do is you're going to take half of the coefficient next to the x, and then you're going to square it. So we'll take half of 8 and square it. Half of 8 is 4. Square it. You're going to get 16. So that'll give me x squared plus 8x plus that 16. And that's going to equal 1 plus 16. What you do to the left-hand side, you do to the right-hand side, right? And if you factor the left-hand side, notice we're going to get x plus 4 quantity squared. On the right-hand side, 1 plus 16 is 17. But yeah, this x squared plus 8x plus 16, it's going to be a perfect square trinomial, and it's going to come out really nice. x plus 4 quantity squared. And that's the whole idea behind completing the square. Before I finish solving this, let me show you how this works, okay? If you had a perfect square trinomial, what that is, it's going to be a plus b quantity squared, and the formula looks like this, right? If you've been watching my videos a couple of units ago where we talked about multiplying polynomials, this is where I introduce the formula. So let's take a look at how I get from 2ab to b squared. Now, assuming that a is a 1, what we're really looking at is getting from 2b to b squared. Well, first you had to cut this in half, right? In order to get rid of the 2. And then you had to square the b to get it to b squared. So that's what we're doing here. We're taking half of the b, so half of the a, and then you square that value to get to your perfect square. And that's how you pick up your perfect square trinomial. In case you were wondering, that's how it's done. So that's why they do what they do here. All right, so let's finish it now. Square rooting both sides. Notice my point I'm at now would have been my starting point for this problem, right? So I had some groundwork I had to set up before I could do this little maneuver. So I'm going to take the square root to both sides. That's going to give me an x plus 4 on the left. Our plus or minus the square root of 17 on the right. Subtract the 4 to both sides. There it is. X is a negative 4 plus or minus the square root of 17. And that's how you solve by completing the square. Stick around. I'll probably show a part 2 on this, on completing the square.